Hi, and today we'll be learning about the crossroad problem, that is the constraint satisfaction crypt arithmetic problem in AIML with the subject code 18CS71. The question is very simple. We are having two different words. One is cross and other one is road. If you add these two, you should get an word called a danger. So they have encrypted something here. Okay, based on this encryption key we have to analyze this crypt arithmetic problem. So what we are doing is we are having crossroads, we have put it into box, and this c1 c2 c3 c4 and c5 is your carry numbers. You can like when you add these two you get one number, and there will be some carrying number also. So that carry, this we have taken 0 to 9 I have taken in a side. Okay, there are 0 to 9 digits are there, so 0 to 9 I have taken initially. Now you see here you want D, so you need one carry here. Obviously this c5 should be a carry, so let me take c5, assume c5 to be 1. Okay, I have taken it as a carry. Okay, so if this carry is 1 means I'll get this box as 1, right? So what is 1? 1 we have assigned it for D. We are done with D, right? Now next we are having, when you add these two digits you should get some sum and there should be a carry here, right? Now what I will do is I have to take one greater number here, so that when I add with a smaller number I'll get some carrying number. So the greatest number is 9. So let me assume that C to be 9. Okay, I am just taking this as 9, assuming C is equal to 9, right? We've got C. Now keep this in your mind, this should be kept in your mind, right? Now what we have is, now we do not know R. What is R? So we have two letters here, S and S. From this can we get R? Yes, we can get. What are we doing? So there is an equation saying that 2S is equal to R, right? This you have got. Now let us assume, say we are assuming R. Since this is 2S, if you divide, R should be even, right? This obviously should be even, right? What and all even numbers is there? R can't be 0, so it should be either 2, right? R should be either 2, or it should be either 4, or it should be 6, or it should be 8, right? Now let us assume R to be 2. If it is R is 2, then S will be equal to 1, correct? Now take wherever S is there and R is there, let us substitute and let us see what values we get. Now C plus, yes, C plus R is equal to A, right? A plus a carry, right? You get A plus 10 we will take because it's carry, right? So now C is what? 9. 9 plus 2 is equal to A plus 10, right? So A will be what? 9 plus 2, 11. So you get 2, correct? Will you get 2? This is a contradictory, right? You can't get 9, 10, 11. 10 minus 11 is 11 minus 10 is 1, not 2, sorry, 1. Will you get 1? This is a contradicting statement. S is also 1 and A is also 1, so R can't be 2. Okay, now let us assume R to be 4. Okay, taking R to be 4. Now if R is 4, S will be equal to 2, correct? Now let us substitute here. So R is 4, right? So now here only let us substitute. 9 plus 4 is 13 is equal to A plus 10. So A will be equal to 3. Okay, we have got some A value as 3. That's okay. Alright, we have got A as 3. Now let us substitute for S place. S plus D is equal to E, right? S is what? 2. D is 1, which is equal to E, and E is again equal to 3. So this and this is contradicting, right? Same. So again R can't be 4. So again we have cancelled with R as 4. Now next, assume okay, R is equal to 6. If R is 6, what will be our next move? S is 3. Now C plus R is equal to A plus 10. C is 9. 9 plus 6 is equal to A plus 10. 15 is equal to A plus 10. A is equal to 5. We've got what is A. Now, S plus D is equal to E. So, S is 3 plus D is 1 is equal to E. So, E is equal to 4. Now, is this both contradicting? No, both are having different values. So, can we write this? Can we fill this? Yes. S is 3. R is 6. 3. 1. E is 4. 6. A is 5. We have got with A and this. Enough. What is left? R, O, N. Correct. Now let us take R, O and N. R plus O is equal to N. Right. This should obviously be a greater number, because R is already 6. If you add anything to 6, it will be greater number, right? What are the digits left now? We are having greater numbers, right? Let us fill here. We know what is this E. We know this is S. We know this is A. And we know this is R. Greatest number is these two, 7 and 8, right? So N it can be either 9, which is almost equivalent to 9. We take greater number, so it can't be 9 since C is already equal to 9. So what are the next two digits left? 7 and 8. Any one should be your N. Now you add any number with this O. What are the numbers left for O? O should be a smallest number. It can't be 7, because I can't get a bigger number here again. If I add 6 with 7, I'll get 13. 3 is already done. If I add 6 with 8, I'll get 14. So 4 is already done, right? Now, what we will do is, we are having only digits called 0, 2, right? We are having these two digits left for us, right? See here, we are having 0 and 2 left, 2 digits. So now, let us take 0. If I take 0, it will become 6. So which is not possible. So 0 is not to go. So if I take 2, I will get 6 plus 2, 8. So N is 8 and O is 2. We are done with these two digits. Now, let's fill here. So R is 6, O is 2 and N is 8. Now left is O, A and G, right? O plus A is equal to G. What is O? O is already 2. A we know is 5. So what is G? So G is equal to 7. So G we got it as 7, right? So we know what is 2. 2 is O. What is 7? G. And this is N. So we got these letters here. So what basically we are telling here is, see, for the number crossroads 9, 6, 2, 3, 3, if you add 6, 2, 5, 1, 3, you get the number. You can add 3 plus 3 is 6. Did you get 6? Yes. 3 plus 1 is 4. Did you get a 4 there? 2 plus 5 is 7. Did you get a 7? 6 plus 2 is 8. Did you get an 8? 9 plus 6 is 15. Did you get a 15 there? Yes. So we say that crossroad and is equal to danger is correct. So this is all about the crypt arithmetic problem. So I hope so you all have understood with this, and just get to know clearly when you're doing this solution. Basically you have to take these numbers and we will be arranging one by one. Start from this end so that it becomes easy, because there is a carry, you can easily take these values. Always you have to assume the values and check whether it is contradicting. If it is contradicting with two variable, means then your assumption is wrong, and then go to a new assumption. That is what we have done here.